Look at our aim for today. Our aim is the same as yesterday. We're going to solve multi-step rate problems using dimensional analysis. Today we're going to see some different types of multi-step rate problems. These are going to be problems that are not basic rate problems. In other words, some of them are going to have more than one situation. Some of them are going to have more than one rate. Okay, so we're going to have to figure out what we need to do about those. All right, a duck flew 18 miles per hour for 3 hours and then 15 miles per hour for 2 hours. How far did the ducks fly in all? So when we look at this problem, it says how far did they fly in all? They flew blank miles in all. Right, so I have two rates here in this problem as I read this problem. 8 miles per hour and 15 miles per hour. And I see linked to each one of those rates is a situation. 18 miles per hour for 3 hours and 15 miles per hour for 2 hours. So this type of problem is a double rate, double situation problem. Double rate, double situation. In other words, it's a problem where we have a situation linked to two different rates. So, this is pretty simple. Yes, sir.
Okay, so my question was, is there a way that we can check our answer to see if we've done it correctly?
Your units check that you set up the work right.
Oh.
The multiplication, you just have to make sure that you do it right. All right. So we have two rates here, so I'm going to write both sets of rates. And for 18 miles per 1 hour, or 1 hour for 18 miles. And I've got a second rate, which was 15 miles per hour, or 1 hour for 15 miles. So we also had two situations, but the situations were very specific to what they counted for. So this 3 hour situation is for this rate. And the 2 hour situation was for the 15 miles per hour. So basically all they've done here is they've put two rate problems in the same problem. We're trying to figure out how many miles. Got a little overzealous with that. I'm going to need that space. So I need to know how many miles for the first rate, how many miles for the second rate. So for the first rate, I have 18 miles per hour. That's how I'm going to get my units to line up here. And the situation is 3 hours. So if we have two rates in two situations, looks like we're just going to be solving two rates. So in the second 2 hours, they traveled 15 miles per hour. And they did so for 2 hours. Hours cancels out with hours for the first one, and that tells me for the first 3 hours, how far did they travel? 3 times 18. 54. For the second 2 hours, using our rate, they traveled 30 miles. Now the question is, how far did they travel in all? Add them together, and you get 84 miles. So, when you have a double situation, or a double rate, double situation problem, all you need to do is solve two different rates. So it depends on what the question's asking you, whether you need to add those rates or subtract those rates or do something different with those rates. So in this particular problem, it clearly says how far did they fly in all. It could have said what is the difference between how far they traveled in the two different times. And in that case, you would have subtracted. Okay? So you just have to be very careful. When you have two rates, two situations, you're going to solve two different rates, two different rate problems, and then determine what you need to do with those numbers. Questions about that? Oscar? Yes. Michael?
Okay, so when it says it all, then why didn't you just add? And why didn't you just add? Why did you multiply there?
So that's kind of an order of operations question. But it's also kind of this idea is you're not traveling 33 miles per hour for 5 hours. If we think about how fast you're traveling 15 miles per hour and 18 miles per hour. Okay? So on average, you're probably traveling somewhere around 16.5 miles per hour. So it wouldn't make any sense to add things together. Yes, sir.
So if it says it all or like the difference, does that automatically mean that it's enough rate?
It may not necessarily. You have to read the problem. And so I think what Michael's getting here is to the key to really recognizing these problems is reading the problem carefully and recognizing in the problem if you have a rate, if you have a second rate given to you, if you have a second situation and a first situation given to you. All right? So looking at this next one. It says 3 minutes into the game, the SF Bay basketball team had scored 12 points. If there are only 30 seconds left in the game, how many points would you expect the team to score? Okay, so we're going to go through the process. We're going to start with this. How many points would you expect the team to score? You would expect them to score? To score blank points. As I'm reading through this, I see it's 3 minutes was 12 points. So that's our rate here. Three minutes for 12 points. Or 12 points every 3 minutes. And the situation we're given here is that there's 30 seconds left in the game. So looking at this particular problem, how many rates and how many situations? Show me with your fingers. How many rates? How many situations? 1. Okay, so this, because it's one rate and one situation, we call this what type of problem?
Basic rate.
Basic rate. So this is definitely not going to be like the last problem. Yes, Mr. Matlock.
Since it said how many points would you expect them to score, then why do you have to do work if you're like thinking like how many points you're expecting them to, not you want them to.
Okay, so looking at this, we need to set up our units. We've got points lined up with points. 3 minutes, so we're able to use our rate here. And now I want to throw in my situation, but if I throw in my situation, what's going to be the problem here? Mr. Ross? Can't cancel out those units. So we've got to get a relationship between seconds and minutes going here. So that means I need to throw in an extra rate here. So I hear somebody calling out that there are 60 seconds in 1 minute. Or we could say that as there are, in 1 minute, there is 60 seconds. So we have to throw one of these in over here on this next line. I need to cancel out the seconds and the minutes just to get those points. So if I want seconds to cancel out, I'm going to need those seconds on the bottom. And seconds with seconds, minutes with minutes. I can do some simplification here. This is going to be 30 times 2. So the 30 cancels out. And so I'm going to get 12 over 2 times 3 is 6. 12 divided by 6 is 2. So this wasn't quite a basic rate problem. We want to come back and rename this one. This was a basic rate with a conversion. All right, so that was a little bit more complex. It wasn't a basic rate problem. But it wasn't also one that had multiple rates or multiple situations. Yes, sir.
Could you have gotten an answer like when it says like 3 minutes for 12 points, right? So just divide that and there's 60 seconds in a minute and each one is 4 points. So just divide that by 2 and you get 2.
Yes, but then you wouldn't have been sure that you had done the right thing. All right, so Marissa's car gets an average of 28 miles per gallon. That definitely looks like a rate. I'm going to box it in as if it is a rate. She plans to drive 200 miles one day and 200 miles tomorrow. How many gallons of gas should she expect to use in all? All right, how many gallons of gas should she expect to use in all? She should expect to use... blank gallons of gas. All right, so as I'm looking back through this one, I'm looking at this and I'm saying, all right, so I definitely have one rate here, and then I'm looking at these other two numbers, 200 miles and 220 miles. Those aren't unlike units. There's no relationship really between them. One is not changing the other. So this looks like we have one rate, 28 miles per 1 gallon, or 1 gallon over 28 miles. And this kind of looks like what? We have two situations.
Yes. Double situations, potential.
200 miles and 220 miles. And so this type of problem is a single rate. Double situation. Single rate, double situation. So we only had one rate given to us, but at that one rate we have two situations. So, Mr. Posey asks, can we just add them together? Does it all happen at the same rate? Does the 200 miles and the 220 miles all happen at the same rate? One's yesterday, one's today, but does it matter what day it is? Is her car still going to get 28 miles per gallon? Yeah, so we can actually put that all together. Because it's happening all at the same rate, we can combine them. Okay? Or, if you feel more comfortable, you cannot combine them. It doesn't really matter. I'm actually going to do this problem both ways so you can see that it works both ways. So I'm going to first set it up as two rates, blank gallons and blank gallons. And let's see, I need gallons on top, so it's 1 gallon over 28. And 1 gallon over 28. And situation 1 is 200. Situation 2 is 220. Right. I'm actually going to use a calculator just because I'm doing this problem 2 times, so I want to save us some time here. And this is going to give me 7.14 gallons. And this is going to give me 7.86 gallons. So if I add those together to find the total, that's going to give me 15 gallons. Now, if we do it the other way, because this is all happening at one rate, and I combine these first, that would be 200. That would tell me that I can use a single situation, 1 gallon over 28 miles. How could you guys let me come over here and not show my units canceling out? It's so much of the work. All right. And so we would put that together in 420, and just doing the math here quickly, because I know this one's going to come out nice and even. 28 goes in 1 time. It's 28. 14 goes in exactly 5 times, 15 gallons. So with these problems, these single rate double situation problems, depending on what the question is asking you, you may want to combine or subtract them. So if it's saying what is the difference in the amount of gallons of gas that you would expect to use, if you wanted to use a single situation, you would need to subtract the 2 situations. Okay, so in this particular case, it's whatever you feel most comfortable with. A lot of people feel more comfortable doing it with 2 rates. That way they just don't have any confusion between double rate and double situation problems, because there's no combining you can do with double rate, double situation problems, because it doesn't happen all at the same rate. Okay? All right. The line for the roller coaster is really long. There are about 200 people in line ahead of you for the coaster. The coaster serves 240 people every hour. How many minutes will it take you to get on the coaster? So, how many minutes will it take? It will take blank minutes. As I'm looking through here, I see 240 people every hour. So that's every 1 hour. That's my rate. 240 people. People. Peeps. Over 1 hour. And I'm looking through. There's no other numbers here, but I'm looking for my situation. I should be looking for a situation, 200 people. These are the number of people standing in line in front of me. These are the people that need to get out of my way. So that's 200 peeps. So here it looks like how many situations and how many rates? 1 and 1. So that means if it's 1 situation and 1 rate, that makes this a basic rate problem. Right? So looking at this, I need to find out, again, how it will take him blank minutes. Looking at my answer sentence. Blank minutes. Here I have a problem. I don't have anything that's going to line up with minutes. I do have something that's very close, which is hours. So what that tells me is that this is not just a basic rate problem, it is a basic rate problem with conversion. So if I'm converting between hours and minutes, what is the rate that I need to write down?
1 hour over 60 minutes.
1 hour over 60 minutes, or 60 minutes over 1 hour. So I want the one that's going to match up my minutes, so that's this one over here. It's going to give me 60 minutes over 1 hour. Now I need to get rid of these extra hours so I can put in my 1 hour over 240 peeps. Not to be confused with the awkward marshmallow candy from Easter celebration. You need to throw those away. All right, peeps cancel out with peeps. Hours cancel out with hours. I can do some simplification here. This is 40 or 60 times 4. That would be even better. And that's going to give me 200 divided by 4, which is going to be 50 minutes. It's a long way to wait in line. All right. So what we see here is that we did 2 problems that were definitely review of yesterday, and we did 2 problems that were new. The 2 new types of problems, one was a single rate double situation, one was a double rate double situation. I think our key points should probably revolve around the 2 new types of problems. Mr. Posey.
When we have a double situation, we should add and subtract them.
Okay, double situation, or single rate double situation, excuse me. Single rate. Double situation. Can be solved by combining situations or doing 2 rate multiplications.
That's so much.
All right. What about those double rate, double situation problems? Andrea. Yep. Double rate. Double situation. Problems must be solved with 2 rate multiplications. Oh no. Shunts. All right, so double rate, double situation problems must be solved with 2 rate multiplications. So for a lot of people, they feel more comfortable doing 2 rate multiplications for the double situation, single rate double situation problems, because that way they only have to remember 1 rule. If there's 2 situations, always do 2 rate multiplications. For some people, that's easier, okay? So you make that decision about single rate, single multiplication, You make that decision about single rate double situation problems, but you cannot make that decision about double rate double situation problems. Double rates mean you have to use 2 rate multiplications. Okay, questions?
No.
All right.